Welcome back. This time we're going to create a square. So you can start out with a couple lines intersecting perpendicularly. I'll trust you with that task. And then this part is going to be pretty easy. Open your compass to whatever length you desire. This looks pretty nice. And I'll place the compass right there at the intersection. And I draw part of a circle. I don't show all of this part, but I'm not too worried about that. What I'll notice is this length and this length, those are equal. So I'm going to put a point where the circle intersects those lines, like so. Now, keeping my compass at that same measurement, I'm going to strike a circle this way. Now you'll notice it's certainly going to cross here, like so. I could draw more of the circle, but that'll be all I really need, like this. Now I'm not looking for that point. That's a neat point, but that's not the one I'm looking for. I'm going to actually come over here and place my compass like this and draw another circle. So I'm basically drawing, you'll notice it comes through here, right through here. Drawing 3 circles. But it's not actually the circles that I'm interested in. It's the intersection of these circles here. There we go. So I'll put a little point right here. I now have a point here, here, and here. So I'll connect those points. There we have it. We've just created a nice little square. This length, and this length, and this length, and this length are all equal. Well, we could see that one as we struck with our compass. So I'm going to call it 1 unit. 1 unit. Well, this is 1 unit and 1 unit also. But what I'm really interested in is taking this square, which has all these nice 90-degree angles in here, like so. These are all 90 degrees, and I'm going to cut it right through here, create a diagonal. There we go. Now what I have is a right triangle with length 1. I'll use pink this time. Length 1 and some hypotenuse. Should I use H for the hypotenuse? Or should I use C so it matches our a squared plus b squared equals c squared? C, you say? Okay. You get to call it. So C it is, our hypotenuse. And again, because we have a right triangle, this little pink triangle is a right triangle. It's actually an isosceles right triangle. We know the Pythagorean theorem, a squared plus b squared is equal to c squared. Like so. 1 squared is 1. When I add those together, I get 2. C squared is equal to 2. Taking the square root, I get the square root of 2. C is equal to the square root of 2. Like so. Well, that was fun, but now my pink triangle doesn't fit in my circle with radius 1. No worries. We can cut it down. Notice the radius here is 1 in our circle, which I have drawn in black. It's a little easier to see. So I'm just going to take my pink triangle and I'm going to shrink it down a little bit. And I think what I'll do is I'll draw that in yellow to say I need to shrink this triangle down so it fits in here. There we go. There's my yellow triangle. Now for this pink triangle to be shrunk down to fit, this C, which for the pink one was equal to the square root of 2, it's now shorter. It actually needs to equal 1. So all I have to do is take this square root of 2 and divide it by the square root of 2. So I'm going to take that and divide it by the square root of 2. I'm going to rewrite this so it's a little bit neater in here. Square root of 2 divided by the square root of 2 is equal to 1. But if I divide that side by the square root of 2, I'm going to need to divide this side by the square root of 2, and then this one over here gets divided by the square root of 2. So it's no longer measuring this pink one, but it's now measuring this yellow one. So again, I'll write it a little neater in here. 1 over the square root of 2. 1 over the square root of 2. And now my yellow square fits in here quite nicely. Well, you did think of this 45 degrees. I could tell you were thinking, hey, we should mark those because those are both 45 degrees. I like your idea there. Because on the calculator this whole time was flashing the sign of 45 degrees. The sign of 45 degrees will be the opposite over the hypotenuse. In this case, opposite 1 over the square root of 2. Let's just write this down. Sine of 45 degrees is equal to the opposite 1 over the square root of 2 divided by the hypotenuse, which is 1 over the square root of 2. Now we could write 1 over the square root of 2 a few different ways. For instance, if I wanted a rational denominator, I could multiply it by the square root of 2 over the square root of 2, giving me the square root of 2 over 2. So let's summarize that. Sine of 45 degrees is equal to 1 over the square root of 2, which is exactly the same as the square root of 2 over 2. Now what is it approximately equal to? Put a little squiggly equals here as we investigate. Since my calculator has been flashing this sine of 45 degrees all along, I'm going to notice that when I enter the sine of 45 degrees into my calculator, it gives me a decimal approximation. Is that the same as 1 divided by the square root of 2? Yes, it is. Is that equivalent to the square root of 2 divided by 2? Yeah, it looks good. So I'm going to write the decimal approximation 0.707. I have to round it somewhere. I'll round it right there.